right. Were there any questions on the do now? No questions? All right, let's start then. Today is the 10th. Can everybody see that? We're going to be working on finding the constants of integration. We're going to be doing level 2 today. After we're done with notes and practice and examples, you're going to have an exit ticket. So remember that we called C the constant of integration? Because we don't know what that is, because when we take the derivative of a function, the constant becomes 0. This is the unknown for an antiderivative. Antiderivative. Derivative. These are the unknowns for the antiderivative. We're going to learn how to solve these today. We're going to learn how to solve these today. As a reminder, so as a recall, we have 2 rules right now. We have the constant rule for integration. Remember, the constant rule for integration is separate from the constant rule for derivatives. So right now we're doing integrals. It says that if I have the integral of some constant, thank you, it's going to be equal to that constant x plus c. When I was grading, and you'll get these back probably by the end of the week, but when I was grading your assessment, some of you did not put the x on your constant. Make sure you're doing that. It does not turn to 0. This integral is different from the derivative. This integral is different from the derivative. The derivative of a constant is 0, but the integral of, or the antiderivative of a constant is whatever that number is plus x, or added with an x attached. We're going to also need to remember the power rule. The power rule says that if I have ax to the n, where a is my coefficient, that marker is ax to the n, where a is my coefficient and n is my exponent, then I add 1 to the exponent and divide by that same thing. Keep in mind you are still reducing this part right here. You have to reduce it. Even if it's not a whole number, you have to reduce it. No decimals right now. No decimals. Some of you were putting decimals on your assessment and some of you were not reducing. So make sure that you reduce.
Are we all sure what we mean by reduce a fraction? So if I have the fraction 6 halves.
Oh, I was about to.
Oh, go for it.
So I have 10 over 5. That reduces to 2, to a whole number.
Oscar.
But
this is your last one.
if I have 6 over 9, that will not be a whole number. This is why we told you to get your calculator if you can't do it in your head. This reduces to 2/3. And this is what should be next to or inside your problem if it reduces. Okay? It has to be reduced, whether it's a whole number or a reduced fraction. Are there any questions on that? Tomorrow when we're doing level 3, I'll go over the mistakes that I saw on the level 3. That mostly had to do, again, with reducing fractions and not dividing negative by negative. Everybody should have this down already in their notebooks, so I'm just going to go. Okay. So we have some steps for integration, or steps to find C. Your first step is you're going to get a problem and it's going to say f prime of x or dy dx or y prime is something. The first thing you're going to do is to rewrite as an integral. So that means you're going to need to write it with the little s looking thing. So it's going to say f prime of x is equal to something. So your first step will be to rewrite it as f, or the integral of whatever that is, dx. Your second step is to, am I going too fast? Okay. Use the correct rule or rules. To find the antiderivative. So sometimes you will need just the power rule, sometimes you'll need the constant rule, sometimes you'll need both. Eventually, when we get to special functions, you're going to need the special function rules. So make sure you know. We will have that sheet, or it will be on the board, because right now I don't have all of them up or all of them printed. So once we get with all of our rules, I will make sure that I have another sheet in the orange folder. Your next step is to substitute the given values to solve for C. So you're going to get a coordinate. You're going to get a function pair, and you're going to need to substitute in this. We did substitution way back. I'm not going to go over substitution. That's why I didn't put it in the do now, because this is something we should know. But you'll see an example in a second, and you're going to solve for C. So you're going to have to do algebra to solve for C. And then your last step is to make sure that you are rewriting as a function or equation. So last week I said it did not matter if you were using y equals or f of x equals. It will matter now, because it's going to tell you, if some of you have looked ahead, it's going to tell you what specific notation to use. So make sure you're using that notation. Are there any questions so far? When you're done writing that down, take out the example sheet. We have 2 examples to do. You've got 4 practice problems. 4 practice problems? I don't remember. And then we have an exit ticket. Bless you, bless you, bless you, bless you. Ready? Okay. This is your first example, right? Yeah. Okay. It says find f of x. So this is what we're going to use. Instead of y, we're going to have to use f of x. This is what our final equation is going to look like. So this is our original function. We need to find the original function, which is also called the antiderivative. derivative. Okay. Additionally, it gives us some information. It tells us that our derivative, so this is our derivative. I know it's the derivative because of the prime. Remember, we did prime for derivative. Is equal to 7. And f of 2 is equal to 9. So this is function notation. What variable does the 2 stand for? What variable does the 2 stand for? Does anybody remember? I heard somebody say it.
It's inside the parentheses.
What variable does it stand for?
You usually say f of something.
What variable does x?
Oh, excellent.
So when we get to that part, you're going to have to substitute in the 2 for x. And remember, this is going to be f of x. Okay. All right, so let's get started. First step. First step, it says to, sorry, let me go back, rewrite as an integral. So I'm going to take the derivative. This is what you put in the integral. That doesn't work. You're going to take the integral of 7. Because this is my derivative. This is the thing that you saw in the do now. And because we're taking the derivative with respect to x, we put dx. Eventually we're going to have other variables, but we'll get there later, okay? Step 2 now says that we are going to use the correct rule or rules to find the derivative. This is the constant rule because the number 7 does not have a variable, so I'm just going to use the constant rule. So I have f of x is equal to 7x plus c. And this is why I said, don't forget the plus c. We are solving for c today. We're solving for c this week and possibly next week. Okay? Don't forget the c. So this is my derivative, my antiderivative, or my original function. I used f of x because it told me to find f of x. If it said find y, do y equals. Pay attention to the problem, okay? Step 3 says that we're going to substitute in what we have to solve for c. So again, like I said, this 2 is x. So wherever there is an x, I'm going to put a 2. Don't forget your parentheses. Are there any questions so far? This is f of x. So I'm going to substitute in 9 for f of x and put my plus c. And now I'm going to solve for c. This is just algebra. 9 is equal to 14 plus c. Subtract 14 from both sides. C is equal to negative 5. A lot of students stop here and think they're done. You're not done because you have to make sure you're rewriting your problem as the original function because it asks you to find f of x. You've not found f of x, you have only found c. So your final equation, or in this case function, is f of x is equal to, we're going to go back to number 2, but instead of c, we have found c, it's going to be 5. 7x minus 5. If you did plus negative 5, that's perfectly fine, but just keep in mind that these two things are the same. Minus 5 and negative 5 are the same. Are there any questions on that problem? What? You okay? Ready? Questions? Are we sure? All right. On your paper, does it say f of x or y? Y? And it says dy dx, right? But everything else is the same? Okay. No? What's different?
It says and passes through the point
0, 2? Sorry. I forgot to change it in the PowerPoint. Alright. Now that's right, correct? Okay. Okay, find y, given that dy dx, and passes through. Alright. So let's look at this example. Now we have an equation because we're going to have to find y. This again is my original equation that we have to find, which is my antiderivative. This is my derivative. I know that because it says dy dx. And it says it passes through this specific point. We're going to need an x and a y. What value is x and what value is y? What always comes first in a coordinate? X. So then what's the other thing? What's the other thing?
If x comes first, what's the other one?
Y. So we're going to have this information to substitute in for our antiderivative. First step, we're going to rewrite as an integral x cubed minus 2x squared plus 3 dx. Any questions so far? Make sure you're putting parentheses because this is more than one term. If you only had if you didn't have parentheses, mathematically you would only be taking the integral of the first term. So make sure you're using parentheses. I'm going to use the power rule and, excuse me, and the constant rule. I have polynomial terms here, and I have a constant here. Y equals 3 plus 1 over 3 plus 1. I'm just using the power rule. 2x to the 2 plus 1 over 2 plus 1 plus 3x plus c. Any questions so far? Again, I used y equals because it's telling me to find y, not f of x. Step 3. I need to substitute in the given values for c. So I'm going to substitute in x for every x and 2 for the only y. Sorry, I went a little too fast. Oops. Make sure you simplify before you start substituting in. I apologize. But this was easy to simplify. There were no fractions or whole numbers I needed to reduce. Any questions so far? So I have 2. What you would do, I need you to pay attention. What you would do if this was not, oh, sorry, there should not. Sorry about that. What you should do is you need to put this in your calculator. Make sure you're using alpha y equals if they're fractions, but that needs to go in your calculator to simplify. You need to put that into your calculator to simplify. This one you don't need to put in your calculator because we have zeros. What is anything divided by 0? 0. What is, I'm sorry, not anything divided by, what is 0 divided by anything? 0. So this is 0 minus 0. What's 3 times 0? 0. What, somebody say 1? So when I simplify this, 2 is equal to C. Am I done? Sorry, we're probably writing it down. I apologize. Excuse me. Am I done? Did I find Y? No, I've only found C. So I need to go back and substitute in C into number 2. But I need to simplify.
Is anyone lost on how we got here? Because she's asking questions and nobody's saying anything, so we're moving forward. But if something looks unfamiliar, or you're not sure how we got somewhere, or even the language that's being used, please say something. I mentioned before, you guys have less than a month left. Everything you're learning now is going to be your final exam. This is not the time to be bashful and let yourself fall behind.
Right now, simplify. Right now, I'm just on the side, I'm writing the simplified version. So you can see where I got these numbers from. Questions? Okay. If there are no questions, we are going to work on your practice problems, which are on the back.